Okay, let's tie it all together and graph the quadratic function, labeling the vertex and the axis of symmetry. So whenever you're told to graph, you should be looking for these four items: the x-intercept, the y-intercept, the vertex, and the axis of symmetry. So let's go through those steps. So first, to find my x-intercept, y is 0. So 0 equals x squared minus 4x minus 5. So to solve this quadratic, I'm going to factor. I'm looking for two numbers that multiply to make -5 and add to make -4. So those numbers are x minus 5 and x plus 1. So using zero product property, if x minus 5 equals 0, x equals 5, and if x plus 1 equals 0, x equals -1. So if I want to look at those as coordinates, it's 5, 0, and -1, 0. Those are my x-intercepts. So now my y-intercept is the opposite when x is 0. So y equals 0 minus 0 minus 5, which is -5. So your y-intercept is always your c value when it's in standard form. So that coordinate is 0, -5. So now that I have my x-intercepts and my y-intercept, I'm going to go ahead and plot them down here on my axis. So I have 5, 0, -1, 0. And my y-intercept is at 0, -5. So now let's find our vertex. Our vertex is x equals -b over 2a, which is 4 over 2, which is 2. So the y value is goes through that point, so that's 2 squared minus 4 times 2 minus 5. So y equals 4 minus 8 minus 5. So 4 minus 8 is -4, minus 5 is -9. So our vertex is at 2, -9, and our axis of symmetry is x equals 2. So if I plot that, I know 2, -9 is down here. My axis of symmetry comes through there. So that's x equals 2. And I'm going to use symmetry to reflect this. If there's 2 here, then there's 1 this way as well. So here is my parabola for this quadratic function, and my vertex is at 2, -9. So I've labeled my vertex and I've labeled my axis of symmetry. My two x-intercepts and my y-intercept was here, and I used symmetry to reflect that point over here to get a nice shape of this curve.